Hello everyone, you are all welcome to lecture number 1346, and today's topic is the types of element of symmetry. We have different types like center symmetry, then axis symmetry, planar symmetry, like that. But today I am going to discuss this one, that is center of symmetry is represented by small I, and also it is known as inversion symmetry. And this center of symmetry is imaginary center for any molecule, and from that imaginary center we have to see how the center is extended from center to upward and downward side, and where the atoms are same or not. And if in case it is not same, once it is extended from center both side, then it is not symmetrical. It is asymmetrical or non-symmetrical. I am just giving the example here. For example, if I am taking like this, one, 2 dichloroethene. So here, if it is Cl, and if it is H and H. So in this dichloroethene, if suppose center is here, imaginary center, so from this center, if it is extended this side, it's same chlorine atom, and if it is extended this side, same chlorine atom, and again if it is extended this side and this side. So all four sides, once it is extended from the center of symmetry, all the atoms are similar, all atoms are present. So such type of molecules are having center of symmetry, and it is called symmetrical molecule. And if suppose I am taking the example of a trichloroboron, so boron is there. So if suppose I am extending, this is the center, imaginary center of this molecule, and if it is here, and from here if I am extending, there is nothing. In the same way, if it is extended from here to here, and again if it is coming here, there is nothing. And that's why this boron trichloride is asymmetrical, You can see here that asymmetrical means once from the imaginary center, that is center of symmetry is there, and from there if it is extended this side, there is chlorine, but again if it is extended upward side, there is nothing. So there is no symmetry. In the same way, this chlorine, if it is extended here, there is nothing, and this one also if it is extended, there is nothing. So in that case, such type of molecules, once they have center of symmetry, and once it is extended from center of symmetry for both sides, if atoms are not available of similar type, then it is non-symmetrical or asymmetrical. Let us take the example of benzene. For example, benzene Benzene is having 6 carbon it is hexagonal, and I am just writing that the 6 pi electrons are delocalized. There is nothing like 3 double bond, they are all delocalized. And let us imagine that the center of symmetry is here. So if you are passing from here to here, from here to here, from here to here, so all extended atoms, they are matching, they have pair, no one is without any matching of the carbon atom once it is extended from center of symmetry. So this benzene molecule is symmetrical. And you see the angle. For each, this angle is 60 degree. Here it is 60. Here it is 60. Here it is 60. And all are 60. 1, 2, 3, 4, 5, 6. So 60 into 6 means 360 degree. And this 360 degree, once it is divided by 60 angle, so it means 6 carbon. So with this calculation, where all these between 2 carbon, there is 60 degree and there are 6 60 degree bonding, and once they are combined together, it will become 360, but there are that 60 degree, if you divide, you will get 6 carbon. And because of that reason, this is hexagonal ring form, and it is symmetrical and stable. The reason is that this 6-member ring means it should be very much unstable. So because of this center of symmetry, it is following, and that's why it is very stable and it is planar. So this is your symmetrical and it is your benzene. So already enough explanation is given by giving the example of 1,2-dichloroethene and trichloroborane and also the benzene. So these 3 examples are enough to demonstrate the symmetry element, and that is known as center of symmetry, which is represented by I, small I. So symmetry elements. The elements of symmetry is a criteria for determining a molecule is symmetrical or non-symmetrical. There are 5 types of elements of symmetry. Number 1, center of symmetry, small I, that I have already discussed, giving 3 examples. Number 2, axis of symmetry, that is given by symbol Cn. And then third, plane of symmetry, that is given by symbol sigma. And then number 4, rotational reflection axis of symmetry is given by Sn. And number 5 is identity, that is given by E. So today I am discussing the center of symmetry, that is in bracket small I, or it is also known as inversion center. The molecule is involved in, it is inverted. Inversion is there, and by that inversion, by maintaining center of the symmetry, I have given the example of benzene and dichloroethene, that how they are extended from the center, imaginary center. They are similar type of atoms on both sides, upward and downward, and that maintains the symmetry. So here, a center of symmetry is on imaginary point in a molecule. such that if a line is drawn from any group of molecule to the point then extended, if you see that when I explained that in the case of dichloroethene, I draw the imaginary center, and from that imaginary center the line was drawn on both sides, downward and upward, and it was maintained because in one case both places were chlorine, in other case both places were hydrogen, extended to an equal distance beyond point of center, and they are maintaining from the center of the molecule, imaginary one, this equal distance, and that maintains the symmetry of the molecule. It means it meets the mirror image of original group. For example, 1,2-dichloroethene and boron trichloride means that is non-symmetrical. If you see in boron trichloride, those three chlorine atoms which are bonded when we are drawing the imaginary center of boron, all those three, they are not extended with the line passing through the center, and other side where it is extended is without any atom. That's why such type of molecules are non-symmetrical or asymmetrical. So it's very clear concept is given how a molecule is maintaining symmetry, and in other case how a molecule is not maintaining symmetry once it is drawn from the center of that imaginary point. Number 2, center of symmetry in benzene. So I have already discussed the center of symmetry of benzene by giving the explanation. The center of symmetry I is symmetry element in which a molecule remains unchanged after being inverted through a point of center. A benzene has a center of symmetry at the center of ring. If you imagine a line passing through the center of ring and extended outward, from center it is extended to outward in both directions, from center this direction and upward and downward directions, then the center of ring, every atom on one side of the center has corresponding atom. So they have corresponding atom from the center every side. Upward side there is hydrogen, downward there is hydrogen, there is carbon. So carbon, carbon, hydrogen, hydrogen is there, and corresponding atom on the both sides. First, every atom on one side of the center has corresponding atom on other side, that is equal distance from the center is maintained. Once there is equal distance from center is maintained, that's why the hexagonal ring of benzene is symmetrical. When you invert benzene through its center of symmetry, the molecule remains unchanged and it looks the same as original. So here in benzene molecule, this demonstrates the presence of center of symmetry I. Once we have seen that center is there and the atoms are extended on both sides with equal distance, that clearly indicates that benzene is having center of symmetry I in benzene molecule. Number 3, importance of center of symmetry or inversion. Inverted benzene is a very important, which explains the benzene's aromatic structure, aromatic character and stability. So for every atom in the molecule of benzene, a corresponding identical atom will be found on the exact opposite side of the inversion center, and this symmetry element indicates a high degree of symmetry which is characteristic of the benzene molecules stability and unique aromatic structure and aromatic character. So this is my humble request to all the part 4 chemistry students, undergraduate students, even postgraduate, that they should try to understand the symmetry of the molecule, asymmetry of the molecule, center of symmetry, all these under group theory, because this property of center of symmetry plays important role in physical and chemical properties. Once again, thank you very much for watching the lecture.